Hello students, welcome back. In this video, I am going to do exercise 2.3 of relations and functions of class 11th. I have already completed exercise 2.1 and exercise 2.2 of this chapter. In exercise 2.1, we learnt about Cartesian product of two sets, and in exercise 2.2, we learnt about relations. In this video, we are going to learn about functions. What is a function? A relation f from a set A to a set B is said to be a function if every element of set A has one and only one image in set B. So this definition we will understand with the help of few examples. So I have taken examples of few relations. Let's see whether these are functions or not. So this thing we will understand with the help of arrow diagram. So the first ones are the elements of set A. So this is set A, this is set B. So elements of set A, I have 2, 3, 4. Elements of set B, 1, 2. So one element only one time we have to write. So here we can see 2 maps with 1, 2 maps with 1, 3 maps with 1 and 4 maps with 2. Here you have to understand one thing. Elements of set A, set B, they are known as images of elements of set A, and same way elements of set A, they are known as pre-images of elements of set B. So if we see 2, image of 2 is 1, image of 3 is also 1, image of 4 is 2. So let's count how many images each element has. 2 has only one image, which is 1. 3 also has only one image and 4 also has only one image. So therefore, if we read the definition once again, see every element of set A has one and only one image in set B. So here each element of set A has only one image in set B. So that means this is a function. Now let's see another relation. So this is set A, this is set B. So elements of set A are 2, 3, 4. See, if any element is getting repeated, we don't have to write it twice or thrice, because whenever we are writing elements of a set, only one time we have to write. We don't have to do repetition of the elements. Then 2, 4, 3. See, the first ones are the elements of set A and the second ones are the elements of set B. So 2 maps with 2 here. That means image of 2 is 2. Image of 2 is 4 also. 2 maps with 4. 3 maps with 3 and 4 maps with 4. So if we count the images of each and every element of set A, so we'll see now element 2. It has how many images? 2 and 4. So 2 has 2 images. 2 has 2 images. 3 has one image, that is 3, and 4 also has one image. So if we compare this relation with the definition, see definition says every element of set A has only one and one image. But here we can see that 2 has 2 images. So that means this is not a function. So every element of set A should have only one image in set B. Now let's consider one more example, the third one, and we'll figure out whether this relation is a function or not. So elements of set A, the first ones are the elements of set A. So elements are 1, 2, 3, 4, 5, 6, then 2, 3, 4, 5, 6, 7. 1 maps with 2. See, from this relation we can find out 2 maps with 3, 3 maps with 4, 4 maps with 5, 5 maps with 6 and 6 maps with 7. So here also again, if we see all the elements, see 1 has one image which is 2, 2 also has one image which is 3, 3 has one image which is 4, 4 also has one image which is 5, 5 has one image 6 and 6 also has one image. So each and every element of set A has only one image, that means exactly one image in set B. So that means this is also a function. Now what is a real function and what is a real valued function. So before explaining this, I just want to do a recap of these three definitions which I have already discussed in my previous video: domain, codomain, and range. See, when we are defining any relation, suppose this is set A and this is set B. Always set A is equals to domain, and we write domain as X. Set B is codomain, and images of elements of set A, this is equals to range. Suppose I have 1, 2, 3, 4, and here I have 1, 2, 3, 4, 5. So all the images I am writing: 1 maps with 1, 2 maps with 2, 3 maps with 3, and 4 maps with 4. So here I'll write what is domain. Domain, see, domain, codomain, and range. All these three are also sets. So that's why we have to write these like we write a set. So domain of this relation is 1, 2, 3, 4. Codomain, as I've told you, domain is always set A. So codomain is set B, 1, 2, 3, 4, 5. And what is the range? So in range only those elements will come which are the images of elements of set A. So here in set B, I have 1, 2, 3, and 4. 5 we will not consider because this is not an image of any element of set A. So range is equals to 1, 2, 3, 4. That's it. Right now let's see what is real valued function and what is real function. So here now we can see a function which has either R or one of its subset as range. So I hope you have understood the meaning of range now. See, in other word, you can always remember domain means value of X and range means the value of Y. Like suppose here I have taken one example. With that example now I'll explain. See, this is a way of writing function f from n to n. That means this n is known as domain, from where I am taking the value of X, and this n is codomain. This is not equals to Y, but the values of Y will come from this because codomain and range, they are related, as range is a subset of codomain. So these things I have explained in my previous video. So we'll write function, we define function like this. So first set it is domain, second set it is codomain. Then range is the value of Y. So whenever we are writing function, we write as fx is equals to Y. In case of function, we can write fx is equals to Y. So this Y is range. Now I have taken here one example. Fx is equals to 2x plus 1. So I can also write it as Y is equals to 2x plus 1. Right. So here whatever values of x I am taking, if the values of X, they are either from R means the set of real numbers or of any of its subsets. See, when we are seeing the subsets of real numbers, natural numbers, natural number is a subset of real numbers, whole number is a subset of real numbers, integer, set of integer is a subset of real numbers, even integers are the subset of real numbers, odd integers are a subset of real numbers, rational numbers are the subset of real numbers. So all these are the subset of real numbers only. So what is mentioned here, if a function's domain is either R or any of its, then it is called real function, or if its range is either R or its subset, then it's called the real valued function. Like here I'll just explain you. Here I can take any value of x. I can take value of x as 1 also. So if I'm taking value of x as 1, here I'll just substitute. So what is the value of y? I'll get 2 into 1, 2 plus 1, 3. So y's value I'll get 3. Now suppose if I'm taking value of x as 1 by 2. So at this place of x, I'll just substitute 1 by 2. Then value of y, I'll get 2. If I'm taking x as 2, 2 plus 1, so 5 I'll get. So here we can see in this example, value of x if I'm taking, so these are the values of y I am getting. So here I can see these are also real numbers and these are also real numbers. X means domain. In very easy way you can remember, X means domain, Y means range. If domain is real numbers or any of its subsets I have discussed here, then the function is real function. If it's range means y is real number or any of subsets, that means it is a real valued function. So in easy way you can remember here. So this example fx is equals to 2x plus 1 is an example of real function and real valued function also. Now let's move towards the exercise. I'm going to start now exercise 2.3. Exercise 2.3. Let's do the first question. Which of the following relations are functions? So give reason. If it is a function, determine its range and domain. So we can, like just an example, this also relations are given to us. So these relations will draw arrow diagram. See any relation with the help of arrow diagram, easily we can figure out whether this relation is a function or not. So first elements I'm going to write as the elements of set A and second ones are the elements of set B. So elements are 2, 5, 8, 11, 14 and 17. The element of second set is only 1. So we can see all the elements of set A, they maps with 1. So that means all the elements of set A. See, I'll just recall the definition. Every element of set A should have one and only one image in set B. So here we can, if we check, 2 has one image, 5 has one image, 8 also has one image, 11 has one image, 14 has one image and 17 also has one image. So that means this is a function. Now if it is a function, we have to write its domain and its range. So domain, as I've explained you, domain always equals to set A. That means elements of set A. So domain is equals to 2, 5, 8, 11, 14 and 17. See, whenever you are writing domain, range or codomain, always write it in the form of a set because these are also sets. Range I have to write. Range means the images of elements of set A. So here image is 1. So this is equals to range. Now let's do second part. So two sets are there, set A and set B. So first ones are the elements of set A. So 2, 4, 6, 8, 10, 12, 14. 2, 4, 6, 8, 10, 12, 14. See all the first elements I've written as the elements of set A. Now the second ones, 1, 2, 3, 4, 5, 6, 7. So 2 maps with 1, then 4 maps with 2, 6 maps with 3, 8 maps with 4, 10 maps with 5, 12 maps with 6 and 14 maps with 7. So we can see here all the elements of set A has only one image in set B. So that means this is also a function. You just have to count the number of images of elements of set A. So 2 has one image, 4 has one image, 6 also has one, 8 also has one image, 10, 12 and 14 also have one image only. So now we have to write, since it's a function, we have to write domain and range. So domain means we have to write the elements of set A. So all the elements we'll write. So 2, 4, 6, 3, 3 is not the element, 2, 4, 6, 8, 10, 12, 14. So this is domain and range. In range, all the images will come. 1, 2, 3, 4, 5, 6, 7. See, range sometimes it can be equals to codomain. But don't think that set B is equals to range. Set B is not equals to range. Set B is equals to codomain. But range means only images. So images of elements of set A. Here in this example, range is equals to codomain. Now let's consider the third one. So in third one, two sets are there, set A and set B. So elements of set A are 1. So only one time I have to write 1, 1, 2 and elements of set B are 3 and 5. So 1 maps with 3 and 1 maps with 5 also. 2 maps with 5. So in this example, we can see 1 has 2 images. So 1 has 3 as well as 5 as its image. So that means 1 has 2 images, but if we see the definition of a function, it says every element of set A should have only one image. But here 1 has 2 images, so that means this is not a function. So every element, very important thing here I want to tell, every element should have exactly one image. So exactly one means not more than one and not less than one. So exactly one. Images should not be 0 also, and images should not be more than one also. Like here images are 2. So with this we have completed first question. Now let's do question number 2. Find the domain and range of the following real functions. So as I've told you, domain means the value of x and range means the value of y, like what the possible values are. So first function which I have here is fx is equals to minus mod of x. First of all, we'll understand what is this mod. Mod means modulus function. Modulus function. See, this modulus function will always gives us a positive answer. Suppose I am writing mod of 2. Mod of 2 is equals to 2. If I say mod of minus 2, so mod of minus 2 is also equals to 2. If I say mod of minus 10, this is equals to positive 10. So modulus function will always gives us positive answer. If the number is negative also, still the answer will always be positive. For positive also answer is positive. For negative also answer is positive. So if I say minus 100, so mod of minus 100 is 100. So answer is always positive. Right, now domain and range we have to find. So this is the function. I'll just write it as y is equals to minus of mod x. So here which values of x I can substitute. So that I have to write. See, in this I can see x I can write as 1 also. And we will check what are the values of y we are getting along with this. So y I am getting, when x I am substituting as 1, the answer of y is minus 1, because this is positive and this minus sign we have. So y is equals to minus 1. Suppose I am writing x is equals to 0. So if I am writing x is equals to 0, so mod x means mod 0. Modulus 0 is 0 only. So minus 0 means 0, because with 0 we don't write plus or minus. So y I am getting 0. Suppose I am writing value of x as minus 1 by 2. So minus of minus 1 by 2. Mod minus 1 by 2 is positive only. But this minus sign we have here. So minus 1 by 2 as answer I'll get. So y's value here I am getting minus 1 by 2. Let's take one more example. Suppose x value I am taking 3. Mod of 3. Again my answer, because of this negative sign, you can see here, because of this negative sign y is always negative. So from here we can see that, so from here we'll decide what is domain and code, what is domain and range of this function. See, domain, you can see any real value I can take. It can be positive as well as negative. It can be fractional also. So that means domain of this, like whatever possible values, like here whatever is possible to substitute as a value of x. So that means here any real number I can substitute. So that means domain of this function is equals to R. R means a set of real numbers. Now let's talk about range. So here you just have to see the values of y, which kind of values of y we are getting here. You can see here we are getting the value of y as 0. Yes, and other than 0, all the negative values of y we are getting. So that means y is equals to or less than 0 till negative infinity it will go, because you can see any value. If I am taking suppose value of here, if I take value of x is minus 100 or plus 100, any value if I take value of x as minus 100, so what will be the value of y? I'll get minus 100. So but always, because of this negative sign, the value of y will be negative only, right? So that means y means range. It is less than equals to 0. So 0 is there. We are getting one of the y equals to 0, and but then it will not be greater than 0. It is always less than 0. So that means it is greater than negative infinity and less than 0. We can also write its range as in the form of brackets if you want to write this open bracket and with 0 closed bracket. So both the ways we can write. So we have written the domain and range of this function. Now let's do part second. You can try to write this question along with me. So as you write, you will understand more. In a better way, you can understand while writing and listening. So let's do second part. So this fx I am going to write as y. So y is equals to square root of 9 minus x square. Now whenever you have to find the domain of this function, this kind of function means the functions which are under square root. What you have to do, see square root, when I am writing the value which is written under square root, it should always be positive, right? So positive means it should be greater than or equals to 0. So this is how we will find its range. We will write this value, the value which is written under the square root, we will write this value should always be 0. Why this value should always be greater than 0? Because say if the value becomes negative, then what will happen? This type of number will become imaginary number. If any value under the square root becomes negative, so that means this number will become imaginary number. But here we are dealing with real function. So because of this value should be greater than equals to 0, then only it will be a real function. Sorry. Now we can solve this inequality and find the value of x. Like a normal equation, we will solve it. So this I can write it 9, I will write as 3 square minus x square greater than equals to 0. This x square I'll shift to other side. First of all, let's do this thing. Here I'll use the formula a square minus b square. A square minus b square is equals to a plus b into a minus b. So this will become, here a is 3 and b is x. So 3 minus x into 3 plus x, which is greater than equals to 0. Now this we can simplify like normal equation. Once 3 minus x is greater than equals to 0, which means minus x is greater than equals to this 3. If we shift to other side, it will become minus 3. So minus 3 is greater than equals to 0. See, whenever we solve inequations, if we multiply both the sign with minus sign, because we want to find the value of x, whenever we multiply both the sides of inequation with x, the sign of inequality will reverse. See, few rules of solving inequations I have done earlier also. I'll share a link of that video in the description. You can go through that and then you can see here how to solve inequations, right? So I have multiplied both the sides with minus sign. So from there I got x is less than equals to, see, minus into minus, it will become positive x. This inequality will get reversed. Again, minus into minus, it will become positive 3. So x is less than equals to 3. Now this part we will equate with 0. 3 plus x is greater than equals to 0. Again we will shift 3 to other side. So I'll get x is greater than equals to minus 3. Because when this positive 3 goes to other side, it will become negative 3. So basically I have got x is greater than equals to negative 3. So in single inequation, when I write, what it will become? So what are the possible values of x? I can also write it as x is less than equals to 3 and it is greater than equals to minus 3. So this is equals to domain. So possible values of x is equals to domain. I have shown how we calculate, and whenever we have to find domain of these kind of functions, we'll always equate this thing, will make this thing positive. Positive in the sense we'll write this value as greater than equals to 0. Now range we have found, range we have to find, domain we have found. So here I just write the domain. So minus 3 less than equals to x less than equals to 3. So this is the domain of this function. So now let's find range. So whenever the functions are under the square root, for that also there is a, see, there are so many methods to find range and codomain of the function, range and domain of the functions. So only one method I am discussing here. See, with the help of graphs also you can find. So there are many ways. Now range whenever we are finding, so what we can do, see here x square is there. Okay, so x square, we know x square is always greater than equals to 0, because see, whenever we are doing the square of negative number also, this is also positive. If we are doing the square of 0 also, it is 0. So basically x square is always greater than or equals to 0. So that's what I have written, x square is greater than equals to 0. Here what do I need? Minus x square. So what I'll do, I'll multiply both the sides by minus sign. So multiply both sides by minus. See, inequation, just now I have told you, whenever we multiply both the inequations by minus sign, so this sign of inequality will reverse. So what it will become? Minus x square less than equals to minus 0 means 0 only. Now I need here 9. See, whatever we need here, accordingly we will multiply, add or subtract. So I needed minus, so that's why I multiplied both the sides by negative. Now I need 9. So 9 I will add. Add 9 on both sides. So this will become 9 minus x square. See, minus x square plus 9 means what? I can write 9 minus x square also. This is same. So this side is 9 minus x square less than equals to, here I'll get 9. 0 plus 9 is 0. When I'm adding 9, so this will become this. Now 9 minus x square is less than equals to 9. See, if this thing is less than equals to 9, so from here one thing we can understand, if something is less than 9, so that means this thing, this full thing will be greater than negative. That is how the range will be. Like in the previous question, if we did the same thing. See, this value, it is decreasing. It is always less than 9. So that means the values will become negative at some point of time. So we can write it. We can write it like this. So this thing will always be less than equals to 9. and greater than negative infinity, right? Now we want square root. Now we want square root because that is the value of y. See, I wrote already y is equals to 9 under square root 9 minus x square. Now when I am doing square root, see, square root of a negative number we can't do, right? So what will happen here? What will happen? This thing will be reduced to 0 and this thing will become y and this will become 3, positive 3, right? So this is the range of this function. So y can be 0 also. The value of y can be 0 also, and it is greater than equals to 0. You can also write in this way, 0 comma 3 with closed brackets. So whenever square root type of functions are there, this way you can use to find the range of these type of functions. So with the help of this, we have found the range, and domain we have already found. So I just rewrite the domain was like this. In this form also I can write minus 3 to 3 in closed bracket. This is equals to domain and this is equals to range of this function. Now let's do the next question. Question number 3. A function is defined by this. So I can write it as y is equals to 2x minus 5. Y is equals to 2x minus 5. Write down the values of f of 0. See, f of 0 means, see, we normally write fx, right? So that means at place of x, what I have to write here? 0. So wherever you see x, you have to substitute x value as 0. So 2 into 0 minus 5. So 0 minus 5, 2 into 0 is 0, 0 minus 5 is 5. So that means y is equals to minus 5. Second part, f of 7. So f of 7 means, see, this is the value of x. So that means x value I have to substitute as 7. So we can do that. Y is equals to 2 into, at place of x we just have to write 7 minus 5. So 2 into 7, 14. 14 minus 5, which is equals to 9. Now third part is f of minus 3. So that means the value of x is minus 3. We can just substitute 2 into, again at this place, at the place of x we have to write minus 3 minus 5. So this is equals to minus 6. 2 into minus 3 is minus 6, minus 5, minus minus plus with the negative sign, which is equals to minus 11. So y's value here is minus 11. Okay, let's do the next question. This was very simple. See, because normally we write fx. So that means fx is equals to f of 0. That means the value of x is 0. Whatever is written inside this, that means that is the value of x we have to substitute. Now let's do question number 4. It's again a similar kind of question. So one function is given to us. What is the function? Tc is equals to 9c by 5 plus 32. See, inside this, whatever is written, this is the notation how we write function. Like in previous question, you see fx. So that means this is the variable. Here, what is the variable? C is the variable in which function we have written. So what I have to find here? T0. T0 means at place of C, we have to substitute 0. So that we can do. So here C is there. 9 into 0 by 5 plus 32. 9 into 0, so 0 plus 32 is equals to 32. Then second is T28, which is equals to 9 into 28 by 5 plus 32. So that also we can do, we'll just multiply first of all 28 into 9, 9 into 8, 72. This is 160. 9, no, 1 second. This is 9 into 8 is 72. 9 into 2 is 18. 19, 20, 21, 22, 23, 24, 25. This is 25. So here this is 252. This also we can write in fraction form and we can take its LCM. 252 plus, if this we multiply 32 with 5, what I'll get? 5 into 2, 10. 160. by whole 5 we can see. Normal calculation is there, only we just had to substitute C's value as 28. So 252 plus 160. So this we will get 412 by 5, right? Next, third part we will do, only substitution is there. Whatever is written inside the this one, that value as a C we have to substitute, like first one we have done. Now C's value minus 10 we have to do. So T of minus 10 is equals to 9 by 5 into minus 10 plus 32. Here we can do cancellation, 2 into 5 into 1, 5 into 2. 9 into minus 2 is minus 18 plus 32. So this, when we subtract, what will we get? 32 minus 18, 14. So it was very simple calculation. Now let's do the last part of this one. The value of C we have to find. See, this is little bit different. Now we have to find the value of C when the value of the function is given to us, right? So little opposite question. What is given to us? TC is given to us 212. What we have to find? We have to find the value of C. So what is the given function? Function is TC is equals to 9C by 5 plus 32. So here this thing's value is given to us. So I'll just substitute here 212, 9C by 5 plus 32. Like a normal linear equation we can solve. First of all, this 32 will shift to other side. When 32 I am shifting to other side, it will get subtracted. As here it is getting added. 9 by 5C. So 212 minus 32 I am doing. So this is 180. 180 is equals to 9 by 5 into C. Now this fraction will shift to other side because C's value we have to find. Let C be on this side only. When fraction we are shifting to other side, this 5 will get multiplied and 2 will get 9 will get divided. You can remember, whenever fraction we are shifting to other side, the fraction it will be written in reciprocal form. So 9 into 20 is 180, 20 into 5 is 100. So we got the value of C as 100. So this was a normal linear equation. So we have done fourth question also. Let's do the fifth question of this one. In each of the following functions, what we have to do? We have to find the range. So same method, like I have told you, same method we will here also will follow, because here it's mentioned x is a real number. Right. And in the first part it is mentioned x is greater than 0. If x is greater than 0, I'll start from here only and I will just write function in this form. Y is equals to 2 minus 3x. See, range means I have to find the value, possible values of y. Right. So y is equals to 2. This fx I have just written as y. 2 minus 3x I need. So x is greater than 0. This is already given to me. Now I need minus 3x. So what I'll do? I'll multiply both sides by minus 3. If I'm multiplying both the sides by minus 3, so here this will become minus 3x, and inequality will get reversed. As I have told you, whenever we are multiplying both the sides by minus sign, inequality we have to change. Here 0, because if you multiply anything with 0, answer will be 0. Now 2 we need. Now we need 2, right? So 2 when I am writing. So now we need 2 on both the sides. So same way we can add 2 on both sides. So when I am adding 2 both sides, so what it will become? 2 minus 3x, because anyhow 2 is getting added, right? So this is just a way of writing 0 plus 2 is 2. So this thing is what? This thing is equals to y. I can write y is less than 2. So what does it mean? Y is less than 2. That means y is less than 2, but it is greater than negative infinity, because its value is continuously decreasing. So it will always be negative, as well as it's less than 2. So that means I can write y is equals to, this way also we can write the range we have found, or you can also write with open brackets also, both. So first one we have found. So its range here I will write. So range is minus infinity to 2. So same way like we found the first one, we did that way also, that way only, like that square root question we did same way. Now let's do second part. Second part, I'll write function y is equals to x square plus 2. So x is a real number and we know this thing, x square is always greater than equals to 2. I've already explained you this thing when we found the range of the previous question, this one 9 minus x square square that time also. And this is a very basic thing that x square, it is always positive and it can be equals to 0 also. So we know this thing, x square is greater than equals to 0. We need x square plus 2. So for that what we will do, we'll add 2 on both sides. So when I'm adding 2 on both sides, what I'll get x square plus 2 is greater than equals to 2. If something is greater than equals to 2, that means the least value of this is 2. I can write this thing as this value. This is what? Y. I can write y is greater than equals to 2. If it is greater than equals to 2, that means it is less than infinity, positive infinity. So its range we can write this way, or also in the form of brackets we can write. So y is from 2 with a closed bracket because of this equality is there here. See, this equality is there. Equality means close. This 2 is included. So 2 to infinity, positive infinity. On infinity, we always write closed bracket, right? So this is the range of this function. So it was very easy. Now third one we have to do, fx is equals to, so this is very simple. Fx is equals to x, that means it's mentioned y is equals to x, because fx is what? Fx we can write as y. So y is equals to x, and x is what? X is a real number. That means x belongs to the set of real numbers. If x belongs to the set of real numbers, as x is equals to y, that means y also belongs to the set of real numbers. That means its range is also set of real numbers as domain. Okay, so with this we have completed this chapter and this exercise. Only one miscellaneous exercise is there that as of now I am not going to do. Maybe in future I will see. It depends. So with this I have completed chapter 2 of class 11th, and I hope you have understood the concept. See, if you have any doubts, please comment in the comment section. Ask me queries, because your comments will motivate me a lot to make more and more videos for you. Thank you so much for watching the videos. I hope to see you in my next one.